Today we are going to learn about Kubernetes Secrets, best practices for secure clusters. We will explore how to securely manage secrets, integrate external secret managers, and implement access control in Kubernetes environments.
Welcome to our video on Kubernetes Secrets, best practices for secure clusters. In this video, we'll explore the vital role secrets play in Kubernetes environments and why securing them is crucial. As Kubernetes is a leading platform for container orchestration, managing secrets securely ensures the integrity and confidentiality of your applications. We'll delve into creating and storing secrets, using them in pod configurations, encrypting them at rest, and integrating with external secret managers. Additionally, we'll cover implementing role-based access control, RBAC, identifying common pitfalls, and monitoring secret usage. By the end, you'll have the skills to manage secrets securely in Kubernetes environments.
Kubernetes secrets are a mechanism for storing and managing sensitive information such as passwords, OAuth tokens, and SSH keys. These secrets allow you to distinguish between configuration data and sensitive data, ensuring your applications remain secure. Different types of secrets can be created, such as Docker credentials and SSH keys, enhancing security by abstracting sensitive data from the application code. It's crucial to understand the difference between secrets and config maps. While both store configuration data, secrets are base64 encoded and designed to handle sensitive information. Mismanaging secrets can lead to serious security breaches, making it imperative to follow best practices for their management. By securing your secrets, you protect your clusters from unauthorized access and potential data leaks. Creating and storing secrets in Kubernetes is a straightforward process, but it requires careful handling. You can create a secret using the kubectl create secret command, which allows you to input sensitive data directly or point to a file containing the data. It's crucial to follow best practices, such as avoiding plaintext secrets in configuration files and using environment variables wisely. For example, you can create a secret for a database password using kubectl create secret generic db password from literal equals password equals my secret password. This command stores the password securely, ensuring it's only accessible to authorized components. Common commands include kubectl get secrets to list secrets and kubectl describe secret name to view secret details. By adhering to these practices, you enhance the security of your Kubernetes environment. Kubernetes secrets can be used in pod configurations by mounting them as environment variables or volumes. This flexibility allows you to securely pass sensitive data to your applications. To mount a secret as an environment variable, you specify the secret in your pod specification under end fields. Alternatively, you can mount the secret as a volume by defining it in the volumes section and then referencing it in the container's volume mounts. For example, a pod configuration may include a secret volume like this: volumes, name, secret volume secret name, my secret. This setup ensures only the necessary applications access the secret. Security considerations are vital. Ensure you limit access to only the pods that require it and regularly audit your configurations for potential vulnerabilities.
Encrypting secrets at rest in EAT is a critical security measure to protect sensitive data stored in your Kubernetes cluster. EAT is the default data store for Kubernetes, and by default, secrets are stored in plain text. To enhance security, it's vital to configure encryption providers in your Kubernetes configuration file, typically kubeapiserver.yum. By enabling encryption at rest, you ensure that data is encrypted before being written to EAT. This process involves defining an encryption configuration file specifying the encryption providers, such as ICBC or a custom provider. After configuring the file, you must restart the API server to apply the changes. Verifying encryption configuration ensures that your secrets are indeed encrypted, safeguarding them from unauthorized access. Regularly auditing your configuration helps maintain a secure environment. Integrating Kubernetes with external secret managers provides an additional layer of security and management flexibility. External secret managers like HashiCorp Vault and AWS Secrets Manager offer advanced features such as secret versioning, rotation, and access logging. Integrating these managers involves configuring Kubernetes to communicate with the external service, often using a Kubernetes operator or custom resource definitions, CRDs. For instance, using the Vault Kubernetes auth method, you can authenticate pods to access secrets stored in Vault. Best practices include regularly rotating secrets, using least privilege access policies, and monitoring access logs for suspicious activity. An example workflow might involve deploying a Vault agent alongside your application to fetch secrets securely. By leveraging external managers, you enhance your security posture and streamline secret management. Role-based access control, RBAC, is a powerful mechanism in Kubernetes for managing access to resources, including secrets. By configuring RBAC, you can define granular access policies that restrict secret access to specific users, service accounts, or pods. And RBAC configuration involves creating roles, which define a set of permissions, and role bindings, which associate these roles with users or service accounts. For example, you might create a role that allows read access to database secrets and bind this role to a specific service account used by your database application. Monitoring and auditing RBAC policies are crucial to ensure they align with your security requirements and identify any potential over-provisioning of access. By implementing robust RBAC policies, you maintain control over who can access sensitive information, reducing the risk of unauthorized access. Managing secrets in Kubernetes requires vigilance to avoid common pitfalls that can compromise security. One significant mistake is storing secrets in plain text, whether in configuration files or environment variables, which exposes sensitive data to unauthorized access. Inadequate access controls, such as overly permissive RBAC policies, can also lead to data breaches. It's essential to apply the principle of least privilege, ensuring that only necessary users and applications have access to secrets. Failing to rotate secrets regularly is another risk, as it allows potential attackers extended access if they compromise a secret. Overlooking audit logs can result in undetected unauthorized access attempts, making it crucial to regularly monitor and review logs for suspicious activities. Lastly, neglecting to encrypt secrets at rest in EAP leaves them vulnerable to theft if the data store is compromised. By addressing these pitfalls, you strengthen your Kubernetes secret management strategy. Monitoring and auditing secret usage in Kubernetes is critical for maintaining a secure environment. By keeping track of who accesses your secrets and when, you can quickly identify and respond to unauthorized access attempts. Tools like Prometheus and Grafana can be integrated with Kubernetes to monitor secret access metrics and visualize them on dashboards. Setting up alerts for unauthorized access or unusual secret usage patterns ensures you can respond promptly to security incidents. Regularly reviewing audit logs helps you understand access patterns and detect anomalies. Integrating your Kubernetes environment with centralized logging solutions like ELK Stack or Splunk provides a comprehensive view of secret access across your infrastructure. By actively monitoring and auditing secret usage, you maintain a proactive security posture, reducing the risk of data breaches.
As we conclude, let's recap the key best practices for managing Kubernetes secrets securely. We've covered creating and storing secrets, using them in pod configurations, encrypting them at rest, and integrating with external secret managers. Implementing RBAC, avoiding common pitfalls, and actively monitoring secret usage are essential steps in strengthening your security posture. Remember, securing Kubernetes secrets is an ongoing process that requires continuous monitoring and improvement of your security measures. We encourage you to apply the skills learned today to your Kubernetes environments, ensuring your applications remain secure. With diligence and the right practices, you can protect your clusters and maintain the integrity of your sensitive data. Thank you for joining us on this journey to secure Kubernetes secrets.